Here is another interesting question under indeterminate forms of the limits. It says find the following limit. The limit of x ln x as x approaches positive infinity. Sorry, a positive 0. Now, we know that as long as we are dealing with these logarithms, there's a reason why we have a positive 0 there, because it's only applicable for positive numbers. So, if I replace here, I'll end up having something like 0. What if I put here ln 0 is actually just infinity. Now I'm having 0 multiplied by infinity. This one is one of the indeterminate forms. It's one of the indeterminate forms that you need to know. And anytime you get 0 multiplied by infinity under a limit, this is what you are supposed to do. All right. For example, let's do this. Okay, before I even solve it. If you have two limits, right, you need to transform it into the form of 0 over 0 or into a form of infinity over infinity, such that you can now use Hoptal's law to differentiate. So here's what we do. So the one that you can easily differentiate, you are going to make it as a reciprocal of itself. I don't know if you are getting the concept. Here is the thing. Which one can we easily differentiate here? X. So this will be the limiting of ln x over, we're going to reciprocate this one such that we have this as x approaches positive 0, in such a way that this becomes, what is ln 0? If I replace here, I'm going to get infinity. 1 over 0 is also what? Infinity. This is a situation which we need to take into. Or we can have a situation where we have 0 over 0. It doesn't matter as long as you arrive at 0 over 0 or infinity over infinity. Whichever you're comfortable with, please proceed. Now that we have arrived at this, we can now use Hoptal's law or rule to work out this. Hoptal's rule allows us or requires us to do what? To differentiate the numerator and the denominator. So if we apply Hoptal's law here, okay, what are we going to happen is this. So the derivative of ln x is just 1 over x over, what is the derivative of 1 over x? Okay, so 1 over x is just x minus 1, which you drop this one, you get negative 2 there, so we are getting negative 1 over x squared, right? So we are getting this type of arrangement. Okay, and of course you can start one of them, they are cancelling out. Are they cancelling out? Yes, of course. So sorry, as this approaches 0 from the positive. So what we have here is the limit as x approaches 0 from the positive. So we have 1 over x. If we cross multiply here, we'll be having multiplied by negative x squared over 1. X and x, so it makes 1x. So we have the limiting of what? Negative x as x approaches 0 from the positive. We now substitute. So if we have to substitute there, what are we going to get? 0. So now you can now see that the limit of this guy here is just equal to what? 0. Boom.